the reactive programming, but with RxJS. So what does that really mean? So we'll talk about some of those things. Well, the first thing is, of course, why do we need yet another programming model like reactive programming? Well, it turns out reactive programming is not really entirely new. A lot of these ideas have been around for quite a while. So essentially, if you really look back at the past maybe 10 to 15 years, we've been developing applications quite differently. Earlier, before 10 years, we used to build applications for employees to use, and we used to give our employees to the customers as access. Well, those are captive users, whereas now we make applications that can be used by real-world users. And even if doesn't matter what your company size is, we can hope that you have more users than employees. Second, your employees are captive users. They may not have a say, but your users are not going to stick around if your application sucks. So as a result, we really need to rethink about how we develop applications. So the first thing is, we have really benefited from cloud computing. If you want to really get the scale, you can start deploying your applications on a cloud. And one of the really nice things cloud gives you is elasticity. You can have services that come to life based on demand. And your demand goes down, services can go down. So you pay as you go. If you have more need, more demand, you pay more. If you have less demand, you pay less. And also, cloud becomes very easy to scale. If you and I maintain this infrastructure, we cannot scale so easily. Whereas the cloud platforms have figured out a way to make that perfectly performant in spinning new servers and killing them. So to build applications for the modern day, reactive programming recommends 4 things. One is to make use of elasticity. Second thing it says is, make your applications message-driven. Having a centralized database and distributed transactions is so 20th century. It makes no sense to build large-scale applications with microservices and disparate systems where they go off and communicate with a shared database. So what you want is different parts of the system come and go, and they can communicate with each other using messaging. Messaging is not new, but reactive programming emphasizes we should leverage that really well. You want applications to be responsive. If an application does not respond very quickly, we live in a day of instant gratification. If your application doesn't respond right away, your users move on to do other things. And you're going to lose users if your application doesn't respond very quickly. So what do we need here? We want applications that are very responsive, because keeping applications responsive is one way to retain the users. If I take a long time and give you the entire result, or I take a short time but I give you a partial result, the second one comes out winning a lot of times. Because if I give you a partial result, there are 2 things that can happen. I'm going to keep your patience because I give you a partial result if you're a human. If you're a machine on the other side, you can start processing the partial result I gave you. You don't have to wait for the entire result as well. So responsiveness is very important. If responsiveness is slow, we're going to lose users, I said. Well, think about infinite scroll. Infinite scroll is a great example of having a system where it gives you a burst of data, but when you scroll down, there's an empty page in the bottom, but before you could realize, it fills in the gap. So that's a great example of being very responsive. You're not giving all the data to the user, you're giving enough for them to use. While they're looking at it, you can go get more. So that becomes really a powerful way to communicate. Then comes along another one, which is resilience. If your application is failing often, nobody wants to use an application that fails. You want applications that are reliable. How do you feel when you enter all the data and before you could submit, your application just crashes? You're going to curse. You're going to be so unhappy. It reminds me of applying to get the visa for Russia. I enter all the data. One of the information they wanted is, what countries have you visited? I'm like, are you kidding me? So I sit there and keep listing it. And everything I enter, my heartbeat goes up because kind of I know a premonition what's going to happen. I come to the last page, I click submit, crash. I was like, okay, thank you very much. This was very helpful. Well, thankfully, what I did was kind of stupid. I copied and pasted everything I entered into a text file. So when it crashed, I had to just repeat it at the next time, right? But you kind of start programming working defensively when that happens. Resilience is very important. So what this really says is, we need to build applications that follow these 4 things. Well, think of this as a data flow. You want to be able to use data flow where you have a stream of data coming towards you, and you want to be able to process this data as time goes on. So this is really a high concurrency and high throughput systems, and you're really dealing with a stream of data, but instead of calling it stream, we'll call it observable. So it's an observable of data. Well, enough talking. Let's see what this means in the way of reactive programming in RxJS. Well, the concept of reactive programming came out of Microsoft research several years ago. Almost every language has what's called a reactive extension. RxJS is one of those for JavaScript. We can create reactive extensions very easily and work with them. So let's look at an example of how this would work. So I'm going to start with an index.html file. And all I have in here is, I have referred to this file called RxJS. And I've downloaded it because the internet connection here is pretty bad. So I downloaded it on my machine before I got to this room. But in general, you could just refer to it from your backend and it'll pull it from there. And then I'm going to create a function called functions.js, which is empty right now. So edit functions.js. We'll come back to what that is in a minute. But what am I going to do here? Excuse me. So I just brought in RxJS. I got an empty file, functions.js. Well, that's good enough for us. Let's play with this. So let's go ahead and fire up the index.html file. So here's the index.html. Now I'm going to bring up a console right here. I'm going to say rx.observable, and you can see there's the observable from Rx. So Rx has an object called observable. What is observable? Observable implements the observer pattern. Well, it's going to give us a stream of data. How is it different from iterator? In a case of an iterator, you pull the data from an iterator. You say next, has next, next, has next, next, has next. In the case of observable, it pushes the data towards you. You become the receiver. An observable can send any number of data. It's usually an unbounded. But what is really cool about an observable is, it's got 3 channels. If you're in my promises talk, you know that we have 2 channels. There's a good channel and the bad channel, right? Well, in the case of observable, there's 3 channels. There's the data channel, there's the error channel, and there's a complete channel. A data channel sends data, an error channel will give you an error, and a complete channel gives you a way to know that there will be no more data. And you can then clean up your resource on your side. So let's see how this is going to work as a real quick example. I'm going to say rx.observable, but I want to emit data through an observable. That's the word. You emit data through an observable. Well, to do this, what we will do here is, we'll go ahead and provide a little button here. We'll create this as input, and we'll say type equals, let's say, let's actually create a button. How about that? So we'll create a button. So the button I'm going to create is called a click. And what am I going to do in this click button? I'm going to simply say on click is equal to, I'll just call a function called click. So I'm going to just call a function called click. That's all I'm going to do. Where is this click function? Well, I'm going to write a function called a click. And what do I do in the click function? I'll just alert. I'll say clicked. So that's basically all I have so far, right? So let's go back and refresh this. There's a button called click. I'm going to click on it. Obviously, that didn't work. So what did I do here? Is it on click with a lowercase click? Anyone remembers this? So fire it up. Click, not yet. Or is it just click? I always get confused with this. I was actually going to write Angular code for a second over there, but that doesn't work here. So what is the function called? Anyone remembers? Is it on click? That's what I tried, right? With a C capital? And that's what I did before. You didn't see that, right? That's what I did, see? It should be text. Why? Button should have a click, right? Why wouldn't a button have a click? How many programmers does it take to get a button click? Type is button? No, it's just a button type. So, recommendation, see on the console. That's called hope. Yeah. The C should be small. We tried that too, didn't we? Click function can be anything you want. Didn't I call it lowercase click? Yeah, I called it lowercase click. And that's in functions. And that's where I am. So let's try this again. So click on it. So what are you saying? Remove the semicolon. Oh my gosh. Fine, I'll follow your advice. So input type equals to what? Submit, button, and then what? How do you handle the click? With the C, uppercase C or lowercase c? There's so many opinions, right? Still not working. See, small, you're saying. All right, I'll Google for it if it doesn't work now. No, come on. I'm not listening to you anymore. So we don't want to waste more time on it, so let's move on. So let's bring up a little code and play with it. This is always a problem when you deal with these kinds of API, right? So this is where you got to keep guessing what the function is. All right. Actually, it is on click with a lowercase click. That's what it's called. So let's go ahead and try this. So here's a button, on click, and then I'm going to call this function called subscribe. We'll call it subscribe. But I'm going to bring in the script, and I did bring in the script, functions.js. And here I'm going to say function is going to be subscribe, and I'm going to use that. It shouldn't really matter, but this is supposed to be on click with a lowercase. At least that's what it is. Otherwise, I'll bring my file function and we'll reuse it here. All right, so there we go. I don't have a clue why that didn't work. Okay, so, all right. So what am I going to do now? Let's get back to what we want to really do. So in this case, what do I want to do here? I want to bring in Rx, isn't it? So Rx, well, first of all, let's go ahead and call a function called primes. Well, the primes function, what is that going to do? It's going to return rx.observable.create. So I'm going to create an observable and return it. That's what the primes function is doing, right? So I could say, for example, const over here, primes, we'll call this as generate primes to avoid confusion. So primes equals, generate, I'll call it generate in a second, primes. So I'm going to call this generate primes and send it. What does the generate primes do? It's going to return an observable to us. We'll come back to that in just a few minutes. We are not done with this yet. We'll come back to it. So what am I going to do in the subscribe? When you call the subscribe, I'm going to go to primes. And I'm going to use that one. But let's come back here. I got an emitter. And what does the emitter do? It's going to emit into the emitter. So I'm going to start emitting some data. But what am I going to emit? So constant emit, let's say function emit. So the emit function says, I'm going to take an emitter, and in this case, I'm going to start emitting just numbers, primes in this case. Let's just say emit numbers, who cares, right? So generate numbers. So I'm going to start generating some numbers, and I'm going to print that out. Well, here's an easy way to do it. Let's go ahead and say let count is equal to 0. And then we could simply say over here, set timeout. So we'll say increment. So what does increment do? Well, increment is a function. So increment equals function. And this says count plus equal to 1. And then it's going to emit. So emitter dot next and sends the count. And once it sends the count, it's going to increment the count, and then it's going to call itself, set timeout, and then it calls increment after, let's say, 1 second. So in other words, what I'm doing is, I'm going to return a create. The create function says, I'm going to take an emitter, and I'm going to start emitting into that emitter. The emit function then says, I'll take a count, but I will increment, call increment. But I'll first emit the count, increment it, sleep for a second, then try it again. Well, this is good so far, but what do I do with all this? So primes.subscribe, that's our next step. So subscribe, you have an observable on one end, and you have a subscriber on the other end. And I'm going to subscribe to this observable. The subscribe is a lot like the then in promise, except it is going to receive the data. So in this case, the subscribe says, when you give me a data, which is going to be a number, and all I'm going to do is simply print out the given number. That's all I'm going to do, nothing else. So all it does is display that number. Assuming I didn't make any errors, we can give this a try. So here's the console. I'm going to click on subscribe, and you can see that it begins to emit. And it emits the data every second, because that's what we told it to do. So this is simply emitting that number at an interval of every single second. But the beauty of this is a chain of responsibility pattern, or chain of command pattern. So you can go to the primes, but before you subscribe, you can say dot filter. Given a number, I want only return numbers that are even. Now, notice when I subscribe, it emits only even numbers. It's no longer emitting the odd numbers. Well, okay, but I really want to take these numbers, but I want to map them to, given a number, return a number times 10. Now you're saying, not only do I want even numbers, but I want 10 times the even numbers, right? So that's why every even number that you get is multiplied by 10, and it's emitting it. This becomes a really nice chain of responsibility, as you can see. So you can take an observable, and you can create an intermediary, which is usually a subject. If you look at this guy, what is he? He becomes a subscriber to upstream and becomes an observable to downstream, right? So I could be getting data from here. I can perform a filter or a map or other operations, and I can start feeding data downstream. So this becomes a very nice way to put together a series of objects that can perform manipulations. If you were in the promises session earlier, or if you're familiar with promises, you can look at the similarity between the two, so striking, right? They both are drawing a pipeline. But the only difference is a promise is a one pass through. Whereas here, it's like your train station. Every 15 minutes, every 30 minutes, every 5 minutes, there's a train going through a platform. Some trains may carry stuff. Other trains may carry people, right? But the thing is, it's the same track, but there are many things that keep going. So it's a stream of data that flows through. And so the observable emits the data, and the data can get transformed until it reaches a destination. But the beauty of this is the tail that wags the dog. If you don't subscribe, the observable won't kick in and do the work. So the subscribe is extremely important. So if I go up here, and I'm going to say, start emitting. Well, in this example, obviously, when I click on it, if I refresh it and click on it, you can see it says start emitting. And it starts emitting, as you can see. On the other hand, if I go back here, and I stop shy of the subscribe, I did not do the subscribe. Now, if I go back here and refresh, and I click on subscribe, now what happened? Well, really nothing. Why not? Because you did not subscribe. Why is that? Well, because an observable is absolutely lazy. It says, hey, look, I don't want to get up and do all this work and find out that nobody cares about what I just did, right? This is like cooking in the morning and realizing nobody's going to be home. And what do you do with all that food? You can't eat all of that, goes waste, right? So what do? You just be smart, just do it on demand, right? So when you know there's a need, then you do it, not otherwise. Being lazy leads to efficiency. So it postpones actually creating it until you actually subscribe, and that's what triggers the evaluation. It's still a push of the data, but the pushing doesn't start until you really subscribe to it. Now, where does this go? Now you can imagine, this is the paradigm shift. The minute you get a hold of this, then you suddenly look around the world, there is a stream right there, right? You can hear the phone ringing. So you can turn around and look at the world around you very differently. Every little thing that can generate a stream of data can turn into an observable. Like what? We'll see a few examples in a few minutes and see how that can become an observable. Okay, so we saw this so far. So we subscribe. We receive the data. You can also unsubscribe and say, thank you, don't send me any more data, I'm done, please. No, it doesn't start kicking until you subscribed. Yeah, but in reactive programming, data streams are very smart. They say, we got the resources ready for you, but only when you subscribe, we're going to start. Example, Netflix. There's a lot of movie on Netflix, but they're not going to start streaming it until you play it, because they are playing it for you. Netflix doesn't wake up in the night and said, I'm going to just play for myself, right? So you need to subscribe, and then it starts streaming the list of movies or even details of a movie or a particular movie. Yeah, right. We'll come back to that later. But even a live video hopefully has one subscriber, right? If nobody is subscribing, if you look at a TV channel, for example, right, they're going to be sending stuff no matter what. But in our programming world, we don't do stuff until there is a real good payback, because otherwise it's a waste of resource. Imagine you're managing a huge server, a farm of servers. You start using resources and there are no users. That's a lot of resources you're going to pay for. You don't want to do that, right? So you'll be very smart about when to play it. Okay, so, but wait a minute, I do want to know that it's completed or not. How do I know this? So let's go back here for a second. Let's put this back. But if you go back here, I'm going to say, well, don't go forever. So do this if count is less than 10, then subscribe, not otherwise. Else what? Else, I'm going to say emitter. Okay, before we go that route, so bear with me for a second. Else, I'm going to say over here, emit next a -1 for no good reason, just to prove the point. So 10 I said, so if I go click on it, you can see it started emitting, and every 10 it's emitting. You know what, let's avoid confusion by removing those filters. So let's remove this for a second. Let's remove this guy also. Let's just directly put the subscribe, so no confusions. So if I go back over here and refresh, you can see that it's sending out every second. But when it hits a 10, what's going to happen? It's going to give you a -1, because that's the last thing we are emitting, so there's a -1. The point I wanted to say here was, if you go to the end, you can say emitter dot complete. So this is a way for you to tell your observer, hey, I'm done. I have no more data for you. Well, you see, it's going to keep sending data. What if I don't have any more data? I have resources on my side waiting for it. And if this guy quietly stops, my question is, did it stop because there's no more data? Or did it stop because it's waiting for more data to come through eventually? It's kind of like somebody is talking, and then in the middle of the sentence, they do this. And you're like, hello? Right? Are you thinking or did you go in coma, right? I mean, on one case you want to call the ambulance, the other case you just want to maybe wait or time out, right? So the point is, how do you know? One beautiful thing about this is it sends data to the data channel, but the minute it sends a complete, the data channel will close up. There'll be no more data. Notice I pushed a -1 in this case, but after I sent the complete. So go back and fire this up. That's 0, 1, 2, all the way down to 10. But when it hits 10, it's going to close the data channel. It's not going to send any more, and bam, the -1 didn't come through. Hey, but how do I know that you're not going to have any more data? Very simple. Remember I said there's 3 channels. The first one is the first channel. As you would imagine, the second is the error channel. So this is going to be error colon plus error. And then the last thing is no data, but I'm going to say over here, done. So to say that I have no more data coming through. So now if I go back and run this, you can see that it's generating data, but because it's going to send me a complete signal, that comes through the complete channel, and as a result, when it hits 10, it's going to say done. So that's a way for us to know that it's not going to get any more data. And as you saw in this example, any data sent after the complete is no longer going to come to me. Well, what if some things go wrong? Well, in a similar way, you can unsubscribe, but I'll skip that part. You can pretty much say unsubscribe and call that. Well, what if there is an error? What are we going to do with it? We'll talk about that in a few minutes. Before that, we'll talk about the so-called hot versus cold observables. What in the world is a hot observable versus a cold observable? Well, to understand this, let's modify the example just a little bit. So what I'm going to do here is I'm going to go back and take this guy. I'm going to just emit data for, let's say, until count is less than, let's say about 100. So let that go for a while, and otherwise I'm going to just stop it. Okay, so but here, I'm going to create a little display. So I'll say span ID equals display. And this is a span tag. And I'm going to say over here, document.get element by ID. And I'm going to send the display to it. So the subscribe method takes a display now. So what is it going to do? Well, in here it says, I got a display coming in, and I'm going to get the prime. Let's ignore these for now. I'm going to get the prime, and what am I going to do with the data when it comes through? I'm going to say, here's the data, which is the number. I'm going to say display.inner HTML is equal to data, right? Let's see if that works. So I go back and hit the refresh over here. And maybe what I should do just for our purpose is I'll put a little dash here so we can actually see it. So right there is the dash. I click on subscribe, and you can see that goes 0, 1, 2, and so on. All right, leave that in there. But what I would like to do is something a little different. I'm going to create a display 1 and a display 2. But then what I'm going to do here is I'm going to send the display 1 to this first one, subscribe. I'm going to then send a display 2 to this subscribe. So I'm going to call the 2 displays. What am I going to do here? I get a display, but notice this prime is exactly the same prime, isn't it? How many observables do we have in this example? How many subscribers? Potentially 2, if I click on those 2 subscribes, right? So the question now is, are the 2 subscribers going to see exactly the same thing, or are they going to see something different? Right? So imagine you're sitting here and watching the talk, and somebody texts you and says, hey dude, what are you doing? Oh, I'm here listening to this talk on reactive programming. And the person walks in, what are they going to see? Exactly what you're seeing at the moment. It's not that they walk in and suddenly I start speaking from the beginning for them while I speak to you currently, right? Well, that is called a hot observable. Hot observable is multiple subscribers see exactly the same thing. That's a hot observable. On the other hand, if you're watching this on a YouTube, and your friend calls you and says, what are you doing? I'm watching this YouTube video. Your friend goes to YouTube, what do? You're on the 15th minute of the talk, they start at the first minute. That's a cold observable, right? So in other words, who is seeing what? Do I as an observable maintain multiple sessions? That's a cold observable. Do I maintain one session? That's a hot observable. I might be on an SMS session with my wife and at the same time with one of my sons. Well, I'm in two different sessions. Mom and I talk about one stuff. Dad and son talks about something else. These are two different sessions. That is a cold observable. Or I can bring them together in one chat. I'm in a group SMS because we three want to decide on something we want to do this weekend. Well, then we three are exchanging messages. I maintain one session and there are two subscribers in this case. So it is up to you how you want to go. The default is cold. So to see this, let's refresh this. Subscribe. Notice I am now in the 5th or the 6th second at this point. Now I click on subscribe. You can see the delay between those two because there are two sessions. So this is a cold observable. So it's like I could be talking to you. Suddenly somebody is texting me. I could be talking to you and texting at the same time, but I'm maintaining two different sessions, right? So there is no connectivity between the two. I have one session for you, one for the person in SMS, and I maintain that separately. Or I could bring them together. How do I bring them together then? Well, if I want to bring them together, it's actually very simple. All I'm going to do is share. So notice, I didn't change the source. I just added a share on it. Primes now is an observable, but with another observable. Again, that is primes up here. This is all the observables. But the middle guy says, I will manage one session for you. This is one of the beautiful things about reactive observables. They're extremely modular, extremely cohesive. They focus on the single responsibility really well. And the observable says, my responsibility is to generate these numbers for you. I don't care about anything else. This guy says, my job is to share the sessions. Potentially what you could do is you could do this. You could take this away from here and you could say over here primes and constant shared primes equals primes dot share. Did you register with primes? Then it's cold. Did you register with shared primes? That's hot. So you can decide where to go. The source is exactly the same still, but it depends on where you came from. If you connected to the source primes, your session is different. If you connect to the shared, you share the session. So if you all connect to here, everyone gets a different session. But if you all connect to here, all of you see exactly the same thing, and you can manage it depending on how you want to handle it. Well, let's throw that away. Let's simply call the dot share right here. Now if we go back here and refresh, and I start firing this up, you can see that it starts to emit every few seconds. But I come in and join now on the subscribe to, and you can see they are in sync. This is an example of that being a hot observable rather than being a cold observable. And there's no one right answer. It depends on the application you are working with. There are times when I am monitoring a system, you come online and say, hey, what's up? I'm going to say, you got to take a look at this. Well, you want the current session. And so you and I should be looking at the same thing for us to collaborate. There are other times you come in and say, what's up? Oh, just go through and run through this for me. Then you are starting anew. The observable may or may not keep all the contents and replay. It might be completely something different. The hot observable decides what to do. You can't control it. But the cold will say, you're going to get the current session, not what current value, not what was there before. That's basically how it's going to work. So far, so good? All right. But how do you deal with errors? We already saw the map and filter operations. We are ahead of this. So we saw how we can do these beautiful transformations. So that brings us to the point, how do we deal with errors? Well, the problem is, if something goes wrong, you want to deal with the error. Now, what do you normally do in Java and a lot of different programming languages? We have really struggled with this. 20 years ago, what we used to do is you call a function, it will return a result to you. If the result is negative, it's an error. If the result is positive, it's a response. And then we realized, wait, results can be negative too. Strike that. Then we said, here's another idea. A function always returns an error. If it is 0, everything is good. If it's non-zero, it's an error. Brilliant. Where's the data? Oh, you send a pointer to the function. And the function will fill the object pointed to and return a 0 if everything went well. If things failed, it will not fill the pointer, but return an error code. That just sucked. One of the problems was we didn't fill the pointer properly. Or person did not send the pointer properly. It's like, okay, that doesn't work. What do we do? Then came along C++ and Java, especially Java. What did they say? They said, we got a brilliant idea. When something goes wrong, we'll throw an exception on you. And the programmer said, I love it. And they started putting empty catch blocks. That doesn't work really well either. And we have been failing at error handling totally in our field, right? I mean, it's insane. If somebody comes and looks at what we do, they're like, are you guys serious? You guys took 50 years and even figured this out? Nope, we're still working on it. What is the worst thing we did? We called it exception. We should have called it normal, right? I mean, it just happens. Stuff happens. What do? Deal with it. What does reactive programming say? Reactive programming says, I'm going to send data through the data channel. If something goes wrong, I'll close the data channel. I'm not going to give you any more data. And I will give you an error through the error channel. How does it give you an error? It gives you an error. It doesn't throw it at you, right? I mean, how rude. Let's be civilized. You just say, I'm sorry, something went wrong. Here you go. And look at, he's smiling right now, right? He's smiling on an error. Have you ever seen people smile on error? Usually like a duck, right? He's throwing stuff at me. So why throw stuff? Be civil. So you're treating error as a first-class citizen. You are returning an error through the error channel just like you were giving data. Let's see how. So to understand this, let's go back to this example right here. And what we're going to do in here is the following. We'll take this one up and say if, well, if, let's say here, okay, so if, rather than emitting, there we go. So if count is greater than 5, we will say emitter.error, sorry, something went wrong. Well, what do I do with this? Notice it sends an error. That's what it's sending. The minute it sends an error, the data channel closes up. There will be no more data. Let's go back to this and see what happens. So I go back here and I click on subscribe, 0, 1, 2, and remember the minute it exceeds 5, it's going to have an error. Did you notice that? There's no more data. What's happening? Well, what's happening here is, the second one here is the error channel. Error display.innerHTML equals error. Let's just display the error, just like we displayed the data. But that comes through the second channel, as you can see. So click, that goes through the data through the data channel, and the minute it runs ground, it says, sorry, something went wrong. So that came clearly through the error channel. So what did we learn? Errors are given to you like they are errors. Even if you blow up, even if this was a throw rather than an error, it'll grab the exception and return to you as an error. And the minute error comes to the error channel, the data channel closes up. You're not going to get any more data. That's based on the concept of circuit breakers. If something fails, you break the circuit until it's fixed. If something fails, you keep asking more. That's called desperation, right? You got to give it a breather and say, I'll let you recover from that. That's what this is doing. Let's put this to something a little bit different and see what we can do with it. So let's get back to this example real quick. I'm going to go to the subscribe, so I'll turn this into a display again. But in this case, actually, let's go ahead and remove this button here. But let's go ahead and create an input. So I'm going to say input type equals text and ID equals input. So I got a little input with me. And I'm going to do something with this input. So what am I going to do? I'm going to go to subscribe, but I'm going to pass document dot get element by ID, and I'll call this as input. So I'll pass an input comma, and I'll pass this display over to the subscribe. And I call this subscribe. So I got two inputs coming in. So what is the first thing? Constant subscribe is equal to function input comma display. Now what am I going to do with this stuff? Well, let's take the input and let's take the display. But we said there can be observable which creates a stream of data. What could be a stream of data? Stock data could be a stream of data. Weather could be a stream of data. Time could be a stream of data. What if a timer becomes an observable? There's a beautiful language called Elm. Elm is written, the syntax of Elm is mostly Haskell, but it compiles down to JavaScript. In Elm, they treat mouse movement as observable. They treat keyboard strikes as observable. Well, what if your keyboard input becomes an observable? What if your mouse movement becomes observable? If you're programming in Angular 2 or Angular 4, you can use what are called reactive forms. When you create a reactive form, you can take a form and say value changes. Value changes becomes an observable. So whenever a user types into a value, it fires an event at you. It emits the data. So we're rethinking about how we program these interfaces. So what we can do here is the following. We can say from event, and then we can use the source. So we will create a get observable is equal to function source. And what am I going to do here? I'm going to say over here, Rx, return Rx dot observable. What method did we call in the past? A create. But now I'm calling from event. This says I want to create an observable, not from a database, not a mocked up thing, not a stock price, but I want to observe this input field. And anytime the user keys up, I want to generate an event. So in this case, we have an observable that is coming from here. But what I can do here is, I can say constant key strokes equals get observable on the input, right? Well, okay, what should I do next? Keystrokes dot, how do I listen to this guy? Subscribe. And what am I interested in? A key. Oh, wait, but I need to get a key from him. How do I get that? Dot map. And what this guy gives you is an event, and you can say event dot key. So I'm going to get an event, and what I can do now is I can say in here, event, and give me an event dot key. So now I have a key with me, and what am I going to do with this key? I can say display dot inner HTML plus equal to the key that has been given to me. Let's see if that works. So refresh, and you can see this guy here. Uh-oh. What did I do on line number 9? Did I call it display 1? Line 11. Oh, in here. Ah. And you waited this long to tell me. Okay, thank you. Good catch though. So go back here. Still, what am I doing wrong? So let's go through this. Here's display. I'm passing the display. Here's the input. I'm passing the input. We don't need to subscribe, you're saying. What line number? Oh, in HTML, what line number? 11. What did I do? Here's the subscribe. I got to click on the button. Oh yeah, I got to click on the button. Yeah, I don't like that. Click on the button. Now it's subscribed, right? Cool. Hey, give yourselves a clap. You did that. Okay, that means you're following this, and I'm not. Okay. So there's the hello, right? It's writing into it as we type it, right? But I can also do this, right? I can say, okay, but dot map. Given a key dot to uppercase, right? So what's going to happen now? So subscribe. Hey, I remembered that now. Hello. But you can also do this. You can say dot filter key. Key is not equal to F. So we can prevent some kind of ugly words being sent. Right? So click on subscribe. Hello. Right? So you can start doing various processing with this, and you can start handling things like keystroke and mouse events. Now imagine that. You become a subscriber to these events, and you're beginning to use functional programming structures. So the ideas from functional programming just become ideas in reactive programming, except you're dealing with a stream of data. In the case of Angular, you are going to see the AJAX call from the server come as an observable. So if your server is just transmitting a stream of data constantly, your HTTP module becomes a HTTP GET, and then you do subscribe on it, and now you're receiving that and processing it on your side through your components and such. So there are two places where you're going to use this. You can start building your own reactive libraries. You can say, I'm going to start doing this. I'm going to give it to other people to use it. That's one option. But a second option is, whether you like it or not, whether you care about this or not, almost every API around us is turning into reactive. This was an aha moment for me to discover, right? Everybody was quiet. And then suddenly everybody got excited about reactive. And the next thing you know, every library that I'm using is providing a reactive interface to it. And so you don't have an option. You don't have a choice. You have to start using reactive because the libraries you're using is reactive. You could say, I don't care. I'm not going to use this stuff. Well, you may not be the one producing observables, but pretty quickly you're going to become the ones using observables, right? You don't have a choice for that. But of course, what you can do with this is you can do some other really cool things. Suppose you notice here, I start typing things. But what if as I type it, I'm going to make mistakes? My wife always says, I'm absolutely phenomenal in typing backspaces. Because she watched me type, you're typing backspace more than actually typing the content, right? So when you're typing this, if I'm typing this and then typing this and typing this, and then I'm going to type that all and remove it, if you have been processing all of that on the server side, on the reactive side, that's a waste processing. You can say throttle. So if you say throttle, you're going to say, let him do this, and then it kind of slows down a little bit, now process it. And then when it's a state of flux, wait again, let it throttle. How do you do that? Well, you can put a throttle of whatever milliseconds, and then you can say, well, of course, don't give me a key anymore. Instead, give me a key dot target.value. Then you get the entire word after it settles down. And if you're going to be doing a search as people are typing, you don't want to be typing for every single thing, because you type some and hit backspace. That's a lot of calls you're going to make to the server, so throttle it. And Rx library already gives you the throttle method you can call, and you can use it. So to summarize what we talked about, reactive programming is here to stay. This is permeating every single thing we are using. So we learned about streams of data. We learned about the 3 channels: the data channel, the complete channel, and the error channel. The minute something comes from the error or complete channel, the data channel closes up. These 3 are 3 distinctive channels. You can take an observable and map it and filter it and do a lot of other operations. I merely scratch the surface, and you can transform the data, and then you can become the observable subscriber on this side, or an observer. And like I mentioned, a lot of different libraries are beginning to use this. If you're interested in downloading the examples, you can go to my site, and you can click on the downloads link. You can download it from there. Thank you very much.